Welcome to Whole Numbers Part 1. This section is for grade 7, 8, and 9. And of course, Part 3 would only be for grade 9. Okay, let's get started. All right, obviously, we're looking at whole numbers, and the first thing we want to do is to understand the whole numbers. All right, so how can we understand whole numbers? Very easy. Whole numbers are numbers that start from 0. If you look at this side of the number line, whole numbers start from 0, 1, 2, 3, 4, 5, and so forth. Okay, so all numbers starting from 0. And unlike integers, whole numbers cannot be negative. As you can see, integers are whole numbers that can also be negative, but whole numbers start from 0 and can only be positive. And of course, whole suggests that the number is a full number. So even though whole numbers is in the family of rational numbers, unlike other rational numbers, whole numbers cannot be fractions, whole numbers cannot have decimals, and so forth. So it has to be a full number. All right. So if we look at the example here, the example of 10.5, of course, that is not a whole number. And because of that 0.5 there, if it was 10 on its own, it would be a whole number. But because of that 0.5, the decimal next to the 10, then it's not a whole number. And a fraction also not a whole number. Okay, moving on. All right, let's look at how we can round off whole numbers, okay, to different contexts. The first context given is to round off these numbers to the nearest 5, okay? So we want to round off the numbers to the nearest 5. And of course, to round off a number to the nearest 5, you need to use multiples of 5. And here's the number line with multiples of 5 from 0, 5, 10, 15, 20, 25, and 30. Okay, so if we want to round off 12, where is 12? 12, that's 12 over there. Okay, at that point. All right, so if you wanted to round it off to the nearest 5, using multiples of 5, 12 is between 10 and 15. All right, it's obviously closer to 10 because if you're going to 10, you'll be going 2 units, 1, 2 units. But if you're going to 15, then you would need to take 3 units. So it's closer to 10, so we round it off to 10. Excuse me. So we'd round it off to 10, okay? So we round that number off to 10. What about 28? 28 is between which two multiples of 5? Obviously, 28 is between 25 and 30. 28 would be there, 28. And we can see that it's closer to 30. Only 2 steps to 30. 173 is between 170 and 175. Remember, we're using multiples of 5 because we are rounding off to the nearest 5. And 173 is closer to 175. Okay, let's move on. Rounding off numbers to the nearest 10. Now, as you can see, we need to use multiples of 10. And the multiples of 10 from 0 would be 10, 20, 30, 40, 50, 60, 70. Those are the multiples of 10. I think that's easy enough for everyone to understand. So if you're rounding off to the nearest 10, then you need to use the multiples of 10. Okay, so between which multiples of 10 is 29? Okay, 29 lies between, in this region, between, the arrow shows you, 29 lies between 20 and 30. So 29 would be there at that point, okay? So that's 29 there at that point. And 29, is it closer to 20 or is it closer to 30? Obviously, it's closest to 30. All right. And what about 74? 74 is between 70 and 80. So that's 74, 71, 72. So 74 would be somewhere there. Okay, 74. So 74 is obviously closer to 70 than 80. So you round it off to 70. Okay. 453 is not on the number line, but 453 is between which multiples of 10? It's between 450 and 460. Remember, we are rounding off to the nearest 10, so we use multiples of 10. Is it closer to 450 or 460? It's obviously closer to that side. It's closer to 450. So we round it off to 450. Okay, you don't always have to use a number line, but I've just used it to make things a little simpler, more understandable. Okay, what about 236? 236 is between which two multiples of 100? 236 is obviously between 200 and 300, multiples of 100, and it's closer to 200. Okay, 913 is between 900 and 1000. Remember, we're using multiples of 100, and it's closer to, okay, rather not 9,000 but 900. Okay, so it's between let's just get that right. So it's between 900 and 1000. 913 is between 900 and 1000, and it's closer to 900, so we round it off to 900. I think we can all see how this goes. The last part, the last question of part 1 is we now need to round off to the nearest 1000. So 3,879 is between which multiples of 1000? It's between 3,000 and 4,000, and it's closer to 4,000. So then we round that off to 4,000. 2,936 is between 2,000 and 3,000, and 2,936 is closer to 3,000. That number is between 9,000 and 10,000, and it's closer to 9,000. Okay, so that's basically how we round off numbers. Okay, let's move on to the next part. Here we're looking at prime numbers. What is a prime number? A prime number is a number that can only go into itself, and 1. Okay, if you take 2, for example, 2 has only 2 factors. It has 1 and itself, right? Another way to look at it would be to say, what product of 2 numbers gives me 2? The only possible option is 1 times 2 will give you 2, no other, right? So that's how we know that 2 is a prime number, because it only has 2 factors. And all these other numbers on the list here are the same as 2. They're prime numbers because they only have 2 factors. 3 will have 1 and 3 only as factors. So that's basically what a prime number is. Okay, let's move on. Factors. What's a factor? A factor is a number that can go into a particular number without leaving a remainder. This part is important. So let's look at the question. The question is asking you, the first part of the question, you need to list factors of 50 and 120. So we're looking at all numbers that can go in. Let's start with 50. All the numbers that can go into 50. Right, obviously 1 is an obvious factor. 1 can go into 50 times. 2 can go into 50 25 times. Now what about 3? Is 3 a factor of 50? Let's check. Okay, obviously not. Okay, 3 is not a factor. Why? Because as you can see, you get 16 and a remainder, so we don't want the remainder, so that means that 3 is not a factor. What about 4? Okay, is 4 a factor of 50? Also not a factor of 50. As you can see, 4 leaves a remainder of 0.5, which we don't want, so 4 is not a remainder. What about 5? Okay, so 5 is a factor. That's why we have it there. 5 is a factor of 50. 5 goes into 50 10 times. 10 is also a factor. You can see how this goes. So the basic method you use to check if a number is a factor, you just divide it into that particular number. Okay, so you can divide any number by 50, and if it goes into 50 without the remainder, then it's a factor. All right, and those are obviously the factors of 120. All right, all the numbers that could go into 120 without leaving a remainder. Okay, so we've listed all the factors of 50. We've listed all the factors of 120. And the next part, we now need to determine the highest common factor. All right, so let's look at everything they have in common. They have 1 in common, They have 2 in common. They have 5 in common. They have 10 in common. And after 10, they have nothing else in common. So obviously, if we are looking for the highest common factor, we're looking for the highest factor that they have in common. In this case, it would be 10. So your highest common factor or your HCF is 10. All right, let's move on. Prime factors. Now, prime factors are obviously prime factors of prime numbers only, okay? So if we want to find the prime factors of a number, then we need to use the prime numbers there. Okay, let's start. Can we divide 200 by 2? Yes. If you divide 200 by 2, you get 100. Can you divide 100 by 2? Yes. If you divide 100 by 2, you get 50. Can you divide 50 by 2? Yes. If you divide 50 by 2, you get 25. Can we divide 25 by 2? No. And then what's the next prime number? The next prime factor is 3. Can we divide 25 by 3? No. Can we divide it by the next one, 5? Yes. So we divide it by 5, and this gives us 5. And of course, 5 we can divide by itself and to get to 1. All right. Remember, when we do this table or the ladder method, you only stop when you get to 1. Okay, so we stop there because we've arrived at 1. Okay, and as you can see, those would be the prime factors of 200. We've got, let's just get that right. What are the prime factors of 200? It's 2. Okay, sorry, 2 times 2 times 2. We've got 3 2s times 5 times 5. Of course, if we wanted to write it in exponential form, we could have written it like this: 2 to the power of 3, because we've got 3 2s, and 5 to the power of 2. Okay, so that is basically how we can write 200 as a product of all its prime factors. Okay, all right, let's move on. All right, the next part, multiples. Okay, multiple is easy. We've already looked at this in part 1. A multiple is basically repeating a number over and over again. So what are the multiples of 100? 100, 200, 300, 400, 500. And what are the multiples of 250? Keep adding 250. 250 plus 250 is 500, plus 250, 750, plus 250. Okay, so you can see how it goes. So we've listed all the multiples of 200, 100, and 250. Okay, now then questions asking you to find the lowest common multiple. Okay, so let's look at what they have in common. They don't have 100, 200, 300, 400 in common, but they have 500 in common. 100 and 250 have 500 in common. What else do they have in common? They also have 1,000 in common. Okay. All right, I'm sure if we continue, we could find more numbers that they have in common. But this question is asking you to find the LCM. In other words, you need to find the lowest that they have in common. And of course, 500 is the lowest that they have in common. So that's your LCM, 500. Okay, let's move on. All right, this part is for grade 9 only. Prime factorization. Okay, prime factorization means you do not list the factors to find the HCF, and you do not list the multiples to find the LCM. So what you need to do is you need to use the prime numbers. Okay, remember we did that for 200. 200 divided by 2 is 100. 100 divided by 2 is 50, and so forth until we got to 1. So let's do the same for 300, because remember we're trying to find the HCF and the LCM, but we must use the prime numbers. That's what prime factorization means. You need to use the prime factors to find the HCF and the LCM. Okay, so all right, I think that should be simple enough to find the factors. Okay, so let's do that for 300. We've already done it for 200, and I will do it for 300. Okay, easy. Can 300 be divided by 2? Yes. Gives us 150. Could 150 be divided by 2? Yes. And this will give us 75. Could 75 be divided by 2? No. The next prime number is then 3. Could be divided by 3? Yes. And this will give us 25. Could 25 be divided by 2? No. Could it be divided by 3? No. And the next prime number is 5. Yes, we can divide it by 5 to get 5. And 5 divided by 5 gives us 1. And remember, we said we only stop when we get to 1. Okay? All right. So now we've got the prime factors of 200 in the first table, and we've also got the prime factors of 300 in the next table. So what do we do if we want to use prime factorization to calculate the HCF and the LCM? We need to list them, okay? Those are the prime factors of 200. It's 2, 2, 2. Okay. The easiest way, okay, what I've already done here is I've listed what they have in common first, okay? So if we look at that, let's just look at what they have in common. All right. So as you can see, they have 2. Okay, let me try that again. So they have 2 in common. They have 2 in common. So I started with those ones, the ones they have in common. They have another 2 in common. So I put those ones down 2. They've got that 2 they don't have in common, but they have 5 in common. Okay. All right, so there's that 5 there, and they've got another 5 in common. So we start by listing all the factors that they have in common, right? And whatever they don't have in common, okay? Whatever they don't have in common, we will list last, okay? 200 has 2, but that 2 is not in common, so we list it at the end. And if you look at 300, 300 also has 3, which is not in common with the factors of 200. So all the ones in yellow are in common. We list them first, and then the 2 is over there is not in common. It's only a factor of 200, and this 3 is not in common. It's only a prime factor of 300. Okay, so very, very easy to do this now. Once you've done this, once you've listed all the ones that they have in common first, and then the ones that they don't have in common at the end, then for HCF, okay, very important, for the highest common factor, when you use prime factorization, you only multiply what they have in common. That 2 they have in common, that 2 they have in common, that 5 they have in common, and that 5 they have in common. So you only multiply only those factors that they have in common. So 2 times 2 times 5 times 5. Okay, this gives us 100. Okay, so for the LCM, you multiply all the factors they have in common, but also the factors that they do not have in common. Okay, so remember we said that 2 is in common, that 2 is in common, that 5 is in common, that 5 is in common, but that 2 is not in common. But to find the LCM, you multiply it also. That 3 was not in common, but to find the LCM, you multiply it also. So for the HCF, the first one, highest common factor, if we use prime factorization, you only multiply the prime factors that they have in common. But for the LCM, you also need to multiply the 2 and the 3 that they do not have in common to get to 600. Okay. All right. Thank you. Please subscribe and like this video if you haven't done so already. Till next time. Bye.